Yeah, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Here in this video, we are going to see about the lead acid battery, which is an important electrochemical power sources. So lead acid battery, as we all know, it is widely used and it is a secondary battery. So what is the construction and working of lead acid battery? You have a terminal, you have the cap, you have the fill that is inside, you have the lead oxide and lead plates that is kept alternatively, and you have the liquid that is filled inside that, probably sulfuric acid, and you have the separator which separates the negative and the positive. So we can see in this diagram how it looks inside the lead acid battery. So let's recall what is the electrochemical fundamentals now. That is, the electrochemical cells, it's a device that converts the chemical energy into the electrical energy through redox reaction at the electrode surfaces. Cell potential, the voltage difference between the electrodes determined by the standard reduction potential of the cell reactions. Oxidation reduction, so oxidation occurs at the anode and where the electron is lost, while the reduction occurs at the cathode where the electron is gained. Electrolytes, ion conducting medium that facilitate charge transfer between the electrodes without allowing direct electron flow. So in this we are going to discuss about the historical development, that is evolution of the lead acid technology from the planet's original design to modern variants, then structural components, detailed examination of the electrodes, electrolyte, the separator and the container materials, then electrochemical reactions, discharge and charge mechanism including half cell reaction and overall cell chemistry. So the perform characteristics includes the capacity, voltage profile, efficiency, and the factors affecting battery lifespan. So its applications is in the automotive systems, backup power, renewable energy, storage, and industrial uses. So when you just think about why lead acid batteries matter, why should we need lead acid battery? So the real world here, the challenge is a hospital has during a power cut, life support equipment, emergency lighting, and the critical medical devices must continue operating without the interruption. Similarly, vehicles require reliable starting power in the extreme temperature from minus 30 degrees centigrades in the winters to 50 degrees centigrades in the summers. So how you're going to define the problem? So we design a rechargeable energy storage system that is reliable, cost effective, capable of high discharge currents, and functions across diverse environment conditions. So this is the definition, that is we are going to identify the problem and define it. So battery construction, it has the key components, that is, you have a positive electrode, which is the cathode, and the negative electrode, this acts as an anode. So lead dioxide active material coated on the lead antimony or lead calcium grid structures. It's used as a cathode. And spongy lead with high surface area, also supported on the metallic lead alloy grade. It acts as the anode. So electrolytic solution is dilute sulfuric acid. It's typically 30 to 35 percentage concentration by weight. Separator. The microporous insulating material, that is polyethylene, PVC or glass made, preventing electrode contact while allowing the ion flow. It acts as a separator between the anode and the cathode to avoid the short circuit. Container and terminals. The acid resistant polypropylene casing with the lead terminals for the external connections. So we'll see the electrochemical reaction during the operation. You can see the discharge process where the oxidation takes place at the anode and the reduction that takes place at the cathode. Oxidation releases two electrons forming lead sulfate, and the reduction, it gives the lead sulfate as well. The overall reaction, you can see that you get an energy, and the cell voltage over here is maintained at 2 volt per cell. So the charging process is the external voltage reverses the discharge reaction. So this charging reaction is exactly opposite to that of the discharge reaction. So the lead sulfate converts back to lead and lead oxide, restoring the battery's energy capacity. So what is the key inside in this is the electrolyte actively participate in the reaction, unlike many modern batteries, acid concentration decreases during the discharge. So performance characteristics of this lead acid battery is 12 volt is the nominal voltage, energy density is 30 to 100, cycle life is 200 to 1000, and round trip efficiency is 70 to 90 percentage. Of course, there are limitations of this. That is heavy weight due to lead content. Sulfation degrades deeply discharged batteries, requires periodic maintenance, sensitive to extreme temperature. So when the temperature is very cold, it will be really tough to start the battery, which is used in the vehicles to start the vehicle. High surge current capability for the engine starting, low cost per unit energy stored, mature well understood technology, excellent recyclability are the advantages of this. So this is the concept map of the lead acid battery. You have the diagram illustrate the interconnected elements, construction compounds, electrodes, electrolyte, separator, electrochemical principle, redox reaction, the ion transportations, performance parameters, and practical considerations. Understanding these relationships is essential for optimizing the battery design and usage. So there are real world applications like automotive static system, uninterruptible power supplies, renewable energy storage, industrial traction power pump. Thank you for your time.